In this second part of lesson 2.5, we're going to look at a couple special types of piecewise functions. Remember, a piecewise function is a function whose value is defined by different expressions. Now, we're going to look at the absolute value function, and then we're going to look at the greatest integer function. So the absolute value function is just one equation, but we know the definition of absolute value, and the definition of absolute value is we know y equals, if it's the absolute value of x, it equals itself for x if x is greater than or equal to 0, and it equals the opposite of x if x is less than 0. So by definition, absolute value is a piecewise function. We're familiar with this, so we don't always have to go back to this definition. So whenever we come across a new function, if we want to find the graph of it, what we can do is we can make a table, plug in a bunch of values, and see if we can find a recurring theme with that. So what we'll do, we'll just plug in several numbers here, -3, -2, -1, 0, 1, 2, and 3. So we'll plug in some x values, and we'll come up with our y value. So we're plugging it in here. So absolute value of -3 is 3. So we have -3, 3. Absolute value of -2 is 2. So we have -2, 2. Absolute value of -1 is 1. So we have this point. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And of 3 is 3. So we have 1, 1, 2, 2, 3, 3. So we have this V-looking thing, and we want to think through it. We don't just want to assume, but we know that pattern will continue. But if you put a 5 in here, the absolute value of 5 is 5 or 7. So it follows this. So we can see that this graph is actually a V shape. It's actually made up of 2 lines. I'm having trouble with this. 2 lines that connect here at the origin, which makes sense because when we talked about this, y equals x is a line. That's this line. Y equals -x is a line with a negative slope, so it comes down this way. So I know it's rough looking, but that should be a V. It goes through the origin. Looking at the next one, we can take the absolute value. So it's actually this function, but then we're going to add 2 to whatever we got. So I'm actually going to go ahead and use this table again, but I'm going to continue it and say we want the absolute value of x plus 2. So this right here is the absolute value of x, and then we're going to add 2 to it. So if we put in -3, it's the absolute value is 3, but then we add 2. So this is 5, because absolute value of -2 is 2, but then we add 2, so we get 4. Absolute value of -1 is 1 plus 2 is 3. Absolute value of 0 is 0 plus 2 is 2. 1 plus 2 is 3. Absolute value of 2 is 2, but then we add the 2, which is 4, and 5. So we're going to graph -3, 5, and -2, 4, and -1, 3. So -3, 5, -2, 4, -1, 3, 0, 2. And so we actually see the same shape coming out again, this V shape. Exact same shape. Well, what's different about it besides the color? What's different is this one here is just shifted up 2. Well, that comes from this 2 right here. We took the absolute value, added 2 to it, so it moved it up 2. Let's look at this one. I'm going to go ahead and just make a new table since we don't have much room there. But we have x, and then we have h of x in this case. -3, -2, -1, 0, 1. Absolute value of -3 plus 3. Well, -3 plus 3 is 0. Absolute value of 0 is 0. -2 plus 3 is 1. Absolute value of 1 is 1. -1 plus 3 is 2. Putting in 0, 0 plus 3 is 3, absolute value of 3 is 3. 1 plus 3 is 4. All right, so we got negative 3, 0. So negative 3, 0. Negative 2, 1. So I'm just graphing these points. Negative 1, 2. 0, 3, and 1, 4. Well, this looks just like a line. But our other ones that involved absolute value was not a line, so we probably should pick some more points here. So let's keep going to the left a little bit here. So we did negative 3. Let's try negative 4 and negative 5. See if that helps out. Negative 4 plus 3 is negative 1. Absolute value negative 1 is 1. And negative 5 plus 3 is negative 2. Absolute value of negative 2 is 2. So we have negative 4, 1. Okay, well, there's our V shape. Negative 5 is 2. So our V is right here. All right, so now let's thinking through our function here compared to the graph. What happened? Well, it's the same shape, but it's moved over 3, and that's where this comes from. It actually moves left 3, and we see a positive 3 here, and that's confusing to some people. So we can think opposite, but the reason is it's what makes this 0. So if I put a negative 3 plus 3, that gives me a 0, and that's why this vertex of the V is left 3 instead of right 3, because it's the value of x that makes what's inside the absolute value equal 0. So this idea that we had an absolute value function, just the absolute value of x, and we added 2 to it, moved it up, added 3 inside before we took the absolute value, moved it left 3. We have these family of functions. Families of functions is a group of graphs displaying similar characteristics. And that's what we just saw with those absolute value functions. The parent function is the simplest graph within the family. So this function right here, y equals the absolute value of x, is the parent function, and these other ones that we graphed in red were related to that parent function. We're going to look at one more special function that ends up being a piece function. It's called the greatest integer function. I like to call it, you always round down. The text we use shows the greatest integer function with just these brackets. There are other ways that are written. Sometimes it actually has brackets that look like this, or sometimes it'll be written like this. And when they're written like this, it puts these bottom kind of bars in here to show that you're rounding down. So the greatest integer function, whatever x value put in, it takes the highest integer possible compared to that number without going over the number. So before we picked several integers, and we can do the same thing here. I'm going to stop here. I'm not going to keep going because there is something that shows up here or that isn't typical like the other one. So what's the greatest integer not greater than negative 3? And that's negative 3. And so what we're doing, I like to use this idea of always round down. Take negative 3, round down to the nearest integer. Well, an integer rounds to an integer. So negative 3 is this point right here. Round negative 2 down. So negative 2, negative 2. Negative 1 just goes to negative 1, 0 to 0. Well, this is really looking like a line. I don't see any end in sight because if we take any integer and we want to round an integer to the nearest ones, it just goes to that integer. So we're going to need to pick some fractions. So yes, 1, 1 will be on here, and 2, 2, and 3, 3, but we need to figure out what's in these other spaces, the non-integers. And so let's pick a couple things here. I'm going to start with let's do 1.2. And we want the highest integer or the greatest integer not bigger than or not greater than 1.2. Well, that would be 1. 1's an integer. If we went up to 2, 2 is bigger than this, so it's 1. And again, always round down. So 1.2 rounds down to 1. So For 1.2, which is about right here on our x value, our y value is 1. What about 1.5? What's the highest integer that's not greater than 1.5? Well, again, it's 1, because if we went to 2, it's greater than 5, and again, it's always round down. We don't use our typical rounding rules, we just round down. So at 1.5, we're at 1. What about 1.8? What's the highest integer without going over 1.8? It's 1. And so that would be there. And so what we notice, anything from 1 up to, this little arrow, 1.999, that will always go to 1. Well, what will happen from 2 all the way up to 2.9999? Well, that will round to 2. 3 up to 3.999 will go to 3. So in these different intervals, so after 1, it stays 1 up until it gets to the next integer of 2. So I would put an open circle here. But once you hit 2, it rounds to 2, and then everything from 2 up to 2.99 is 2. But then when we hit 3, we're up to 3. And so this little pattern would continue. And down here, the ones that get tricky to think through sometimes are the negatives. And let me put just one more space in here. Let's just pick a number. Let's say we want negative 5.3. And we want to round that to the highest integer not bigger than negative 5.3. And a lot of people will say, well, that rounds to negative 5. But if we think of a number line, here's 0, here's negative 5, here's negative 6, here's negative 5.3. Where do we need to round down to? Well, we need to round down to negative 6. So we're thinking to the left. What's the integer, the closest integer to the left of negative 5.3? And it is negative 6. So be careful when you get in your negatives to think through it. We don't want to round up to negative 5. We have to round down. So this pattern continues. This is the parent function of other absolute value functions. Of other greatest integer functions. This is also sometimes called the step function, as you can look at the graph and see why it would be called the step function. Sometimes it's called the floor function. Floor function because you always round down, so floor is lower. The domain. Let's think through that. The domain, if we collapsed everything to the x-axis, we would just get all real numbers. What about the range? Well, these are little tiny segments, so if we collapsed everything to the y-axis, you would actually only get these values here, which are the integers. So the range are actually the integers. Is the set of integers. All right, our last example here, we're using these brackets, so this means the greatest integer function. Or here we can think especially round down, so we want to evaluate all these. So f of 2, if we round 2 down to the nearest integer, we get 2. F of 3 halves. Well, 3 halves, let's think of as a mixed number, it's 1.5, so 1.5 would go down to 1. F of negative 1/5, and we're in the negative, so we have to be careful. Negative 1/5, that needs to round down, so it would be negative 1. So if you think of a number line, here's 0, here's negative 1, about here's negative 1/5. Remember, we always round down, so what's the number or the integer directly to the left of our number? It's negative 1. And then f of negative 5, well, that's already an integer, so it's just negative 5. So that is a lesson on absolute value function and the greatest integer function. And we will be using this idea of family of functions throughout the course, having the parent function and then other functions that have similar characteristics.